So this is the first question I have taken. Like this type of question till now in GATE it not has been asked. So in this question, a semi-converter circuit is given. Okay, and the change here is input to this circuit is this. This is the VS. VS is given here. This is the source voltage. Normally, if question is asked in the GATE exam, their source voltage will be sine wave. So here, what I have taken a, this kind of Passi square wave as a input here. This will be the source voltage, and these are the data which we have to calculate. So first, we have to calculate what will be the average output voltage, RMS output voltage. Okay, and RMS current of the T1, D2, D3, and T4, and what will be the RMS value of the source current. Okay, and the final we will calculate as average power delivered to the load. So I will give 1 minute of time. This average voltage, can anyone calculate what will be the average output voltage? Or sometime I will wait. It's easy only. See this T1 I am firing at 90 degree, this thyristor, and this T4 is fired at 180 plus 90. So what will be the value of alpha? Alpha is equal to 90 degree. And this is the one 2 pi cycle waveform input source voltage. So this is starting from pi by 3 to pi, and again pi plus pi by 3. So 4 pi by 3 to 2 pi. But see here firing angle I am giving as T1 as alpha and T4 as 180 plus alpha. Okay. Should I explain or can anyone reply?
Sir, alpha means pi by 2 na sir.
See, yes, alpha means pi. This is the source. This is the source voltage, not the output voltage. Okay. This is the
Okay.
source voltage. Voltage applied here. But this thyristors I am firing at alpha is equal to 90 degree, and this at like means this is fired at here and T4 fired at here. Similarly, this pattern will be repeated. Okay. Is it clear now? So,
Okay, sir.
see, I will explain only. 1 second. I am going to draw the output voltage waveform. Okay. So, what will the output voltage? I am firing at pi by 2. Okay. So, see, here the waveform, so it will start from here. Okay. So, pi by 2 to pi, this is pi, let's say this is pi. So, pi by 2 to pi, it will be, output voltage will be, amplitude is 100 only. And again, here pi plus pi by 2 means 3 pi by 2 to 2 pi. This will repeat. So pi by 2 to pi and 3 pi by 2 to 2 pi. This will be the output voltage. Anyone have doubt in this? How I have drawn? Otherwise, I will repeat again.
Clear, sir.
Clear. Okay. So here we can directly calculate the average voltage. What will be the average voltage? Average voltage will be 1 by T into, see here time period is pi only. We can see here this is time period is pi only. So 1 by T into area. Area how much? 100 into pi minus pi by 2. This will be pi by 2. So output average voltage will be, it will be 50 volt. Is it clear? What will be the RMS value? RMS will be just, it will be like on time divided by total. So pi by 2 divided by pi into 100. So it will be 100 divided by root 2. This will be the RMS output voltage. Okay. So now what we have to calculate? Further we have to calculate the RMS value of T1, D2, D3 and T4. So now I am going to draw the waveform of the T1. Okay. So when this T1 and T1 will be fired at alpha, so alpha to pi here to here, T1 and D2 will conduct. Okay. At this point, since T4 is fired at here, see, no, here, 1 second, 1 second. I've done some mistake here. See, here I'm not firing this one. I'm firing at pi by 2. It is firing at pi by 2. So pi by 2 here, T1 and D2 will start conducting here to here. Which will conduct? T1 and D2. Again, when this will be turned off here till pi, so what will happen? Anyone tell? See, so here to here, what will happen? D2 and D3 will do the freewheeling from here to here. D2 and D3 will do the freewheeling. Okay. Again, it will do till 3 pi by 2. D2, D3 will do freewheeling 3 pi by 2. Again, T4 is fired at here. So here to here, T4 and D3 will conduct, and again this part, which will conduct. Am I audible? See, I will explain this with respect to the output voltage. Output voltage waveform already have drawn here. See, here the output voltage waveform. So here pi by 2 to pi, T1 and D2 will conduct. Okay. Again here D2 and D3 will do the freewheeling. Again here T2 and T4 and D3. T4 and D3 will conduct here. Again here D2, D3 will do the freewheeling. Okay. So I am going to draw the T1 waveform. What will be the T1 waveform? It will be pi by 2 to pi. Okay. And T2 waveform will be T4 waveform will be from here 3 pi by 2 to 2 pi. This is pi by 2, pi, 3 pi by 2, and this is 2 pi. Okay. And again we can draw the diode waveform. So D2 waveform will be pi by 2 to 3 pi by 2. So D2 will conduct from pi by 2 to 3 pi by 2. Okay. Is it clear till now how I have drawn? Otherwise I will go to the circuit and again I will explain.
Sir, third waveform, sir.
Okay,
That pi
see,
by 2, 3 by 2.
see here. So when this output voltage is appearing, like here we are firing at pi by 2 to at pi it will stop. So see here T1 D2 is conducting. Okay, T1 will be turned off here, and when T1 will be turned off, in that case D2 D3 will do the freewheeling. This D2 and D3 will do the freewheeling. Okay, so from here to here D2 D3 is conducting. Here to here T1 D2 is conducting, and again here we are firing T4. So T4 D3 will conduct till here. Okay, again here this waveform is not there. So in that case D2 D3 will do the freewheeling. Is it clear?
Third waveform is for D2, sir.
Yes, sir, D2. So pi by 2 it will start from here and it will go to 3 pi by 2. So D2 is freewheeling here and it is conducting here. So total D2 period will be pi by 2 to 3 pi by 2. Now it will be clear, I think, to all. Okay.
Sir, D2 conducting from 0 to 3 by 2, no, sir. D2, sir.
1 second, 1 second. Again, I have. Yes, yes. 1 second. Wait. D2, D3 will conduct here. Again, D2, D3 will conduct here. 1 second. Yes, yes, yes. Correct only. And D3 will conduct here. Yes, you are correct only. 1 second. See, here we are T1, D2 will conduct. And again here D2, D3. And here also D2, D3. So total will be how much? 0 to 3 pi by 2. It will be 0 to 3 pi by 2. Okay, and for D4 also it will be same only, because here pi by here from D where it is conducting, like here D2 till here, and D3 will conduct with this a smaller part here, and again it will conduct for this bigger part. So it will conduct initially, D3 will conduct initially here, and again it will conduct for this bigger part. The total will be 3 pi by 2 total. Is it clear? I have missed this smaller part. Is it clear?
Yes, sir. Not clear, sir.
Okay, so total now we can calculate easily what will be the RMS value for T1 and T2. So T1 and T2, IT1 RMS should be equal to IT2, should be equal to how much time it is conducting? Pi by 2, and total period is 2 pi. So it will be pi by 2 divided by 2 pi. Pi minus pi by 2, it will be the duration of T1. So it will be how much?
0.5 amps, sir.
So this magnitude is 10. See, output side we are supplying to a 10
So
ampere
10
current,
amps.
10 ampere current source. So this will be 10. So amplitude will be 10. So it will be 10 into 10 divided by 2. So it will be 5 ampere. Is it clear?
Yes, sir. Yes.
Now you can calculate for this one also in same way, like 3 pi by 2 divided by 2 pi. So 3 pi by 2 divided by 2 pi into 10. So this will be how much? Under root 3 by 2 into 10. So 5 root 3 it will be, I think, or ID2. Is it clear? Now I am coming to the main question, which will be main concept in this question. What will be the average output power? This value we have to calculate. What will be the average output power delivered to the load? Okay. So how we can calculate average voltage waveform? We know output voltage. Okay. So average formula already I have told. VO average is equal to 1 by T VI dt. No, this is power average. EO average is equal to 1 by T VI dt. So what we are observing here, we are observing that current is the constant here, 10 ampere. So what we can apply? I am taking as outside, I into 1 by T V dt. So here it will be the average of the voltage. Okay. So directly what we can do for output power? So PO average will be, it will be
500 watts, sir.
50 into 10. It will be 500 watt. So this type of question can be asked in GATE. Like they will give either voltage or current waveform. You have to calculate the average value there. If one term is constant, it will be 15 to 10. It will be 500 watt. Is it clear to all?
Yes, sir. Sir, for ID3, how, sir?
See, ID3, I will explain once. See, D3 is conducting
RMS
from,
values.
okay,
RMS values, sir.
RS will be same. See here to here pi by 2. Okay. Again, it is
Uh,
conducting from how much? Like here pi to
Pi to 2 pi, sir.
2 pi. So pi to 2 pi, how much? Pi and plus here pi by 2. So how much it will be? 3 pi by 2 total.
Okay.
Total on time will be 3 pi by 2. So what we are doing? On time divided by total time. So it will be
Okay.
same
Okay.
only. It will be same as this
Okay.
one only.
Okay, sir.
Is it clear to all up to now? Like it's a easy question only. Just what I have done, I have changed the sinusoidal input waveform with some like rectangular kind of waveform. Should we move to the next question?
Yes, sir.
Okay. So the next question I'm going to explain is the boost converter question. A boost converter normally we are analyzing without like this resistance. So here what I am giving, this is the internal resistance of the inductor. Okay. And here values are given as this small r is 0.1 and capital load resistance is 10 ohm. So here we have to calculate what will be the value of duty at which the gain of this converter will be maximum. So if we are seeing ideal boost converter, so what will be the equation? VO is equal to 1 by 1 minus D, 1 by 1 minus D into VS. So if anyone will ask you what will be the maximum value of this one, so at which duty ratio it will be? D is equal to 0.5, we can say that this output voltage will be maximum. Okay, but this will not work here since here the practical resistance is given. So I'm going to do the volt second balance and ampere second balance analysis. So one by one I will explain. VL. I'm going to write the VL equation and IC equation. So this is the IC, okay, and this is I naught, and here it will be VL. So one external resistance will be there. This is R, like this is the internal resistance of the resistance, and this will be VL plus minus VL. So VL will be for on time and off time. So when the switch will be on, we can write VL as Vs minus IL into R, and when the switch will be off, in that case what we can write, VL is equal to Vs minus IL into R minus V naught. And what we can write, IC will be when this switch will be on, IC, this diode will be off, so IC will be minus I naught, and when this switch will be off, in that case this is the inductor current IL, so IC will be IL minus I naught. Is these two equations are clear to all? Anyone have doubt in this equation, or should I explain further?
Yes, sir.
Okay, so I'm going to apply
Okay, so I'm going to apply.
volt second balance. So volt second balance across inductor voltage. So what we can write, D into on time voltage, so D into Vs minus IL into small r plus 1 minus D into Vs minus IL into a small r minus V naught. This should be equal to 0. Okay. So further we can see here that this Vs minus ILR and Vs minus ILR, this is multiplied by D, and here it is multiplied by 1 minus D. So if I am taking Vs minus ILR into common, so D plus 1 minus D it will be 1. So we can write as Vs minus IL into R minus V naught into 1 minus D is equal to 0. So this I am taking as equation 1. Okay. Further, for capacitor also I can apply the same thing, ampere second balance. So ampere second balance across the capacitor current. So what we can write, D into, see, minus I naught plus 1 minus D into IL minus I naught. Okay. So from here we can see that this minus I naught will be common. So D plus 1 minus D it will be 1. So minus I naught plus 1 minus D times IL be equal to 0. And here we can write that IL is equal to IO by 1 minus D. So I naught we can write as V naught by R. So further we can write a V naught by R into 1 minus D. This will be the second equation. Up to now it is clear to all?
Sir, please explain this volt's second equation.
Okay, see, volt second means on time voltage area and off time voltage area should be like equal. Okay, area under average voltage for periodic average voltage will be should be equal to 0. Like average voltage across any inductor should be equal to 0, that we called as volt second balance, and average current across any capacitor should be equal to 0, that is called as ampere second balance. So how we are calculating, on time voltage we are multiplying with duty, and off time voltage we are multiplying with 1 minus duty. So this both should be equal to 0. This expression should be equal to 0. Is it clear?
Okay.
So how we can say that, say let's say we are drawing voltage across inductor. Okay, this is voltage across inductor, this will come in some this way. So this is 1 minus D, this is D duty, and this section will be 1 minus D. Okay, and this is inductor voltage waveform. So here it will be this value, like whatever I written, Vs minus ILR. Let's say this amplitude is Vs minus ILR, and this will be Vs minus ILR minus B naught. This will be the negative amplitude, and this will be positive amplitude. So what is the average value? Average value is the area. So what am I doing? This will be the negative magnitude here. See here, just so over value will be negative, but I am taking it as a positive only. So value, so this will overall will come as negative. Okay. So what will be the area? Area means positive area plus negative area should be equal to 0. Okay. So that only I have done here. I have multiplied this will be positive area plus this is the negative area should be equal to 0. It means we can say that average voltage across inductor is 0. Is it clear now?
Yes, sir.
Okay. So coming to next, like, one second. So this equation 2 I am going to put in first. So first already I have written here what is Vs minus ILR minus V0 into 1 minus D. So Vs minus IL. So IL I am going to put this one minus V1 V0 by R into 1 minus D, IL into a small r minus V0 into 1 minus D. V0 into 1 minus D should be equal to 0 from first and second. So what we can do, we can multiply 1 minus D. So 1 minus D Vs minus V0 R by R, okay, minus V0 1 minus D square should be equal to 0. So what we can do further, it will be 1 minus D Vs be equal to V0 R by R plus 1 minus D whole square. Okay. So what will be the final gain equation? Final gain equation will be VO by Vs we can write as 1 minus D divided by 1 minus D square plus R by R. Is it clear to all? This
Sir,
will, yes.
sir, what is small r in this equation?
Which one?
Small r.
A small r is the resistance of this inductor. So this is a practical inductor. This resistance
Okay,
is
sir.
not ideal. So this is a practical inductor. Considering this, I have derived this gain equation. So if any question will be there like this, in that practical resistance will be given. So we can apply the gain equation like this. What will be the V0? So V0 we can directly we can calculate with this equation. So this you have to memorize. This is a standard formula we have to memorize. So now the question is, what will be the value of duty? What will be the value of duty at which this gain will be maximum? Gain means VO by Vs will be maximum. So we have to calculate that particular duty value. So how we can calculate? So we can differentiate this with respect to D. Okay. So I'm going to do that. So what we can write? D V0 by Vs differentiate with respect to dd should be equal to 0. Okay. So this numerator will be a square. So we can write as 1 minus d square plus r divided by r whole square. Further here it will be 1 minus d square plus r by r. And what is the second term? Second term is 1 minus d. So differentiation will be minus 1 into minus 1 minus 1 minus d is there already, 1 minus d, and this term total differentiation will be 2 into 1 minus d into minus 1. This should be equal to 0. Is this u by v differentiation is clear to all? This is the,
Yes, sir.
okay. So here I am going to simplify this further. So it will be 1 minus d square will be minus r by r. Here minus minus it will be plus. So 2 into 1 minus d square. This should be equal to 0. So what we can write, 1 minus d square should be equal to r by r. And what should be the d? D should be equal to 1 minus under root r by r. So at this value of d, we will get the maximum value of the gain. Is it clear to all? So in some question, it
Sir,
will be,
this equation,
yes, you can ask again.
sir, this formula is valid and this type of question only.
Yes, like if it will be asked like what will be the max value of duty ratio for which gain will be maximum. Okay. Otherwise, what will be the range of duty ratio? It will be asked in the question. So duty ratio should be equal to 0 to this maximum duty ratio. Okay. If we are operating after this duty ratio means we are de-utilizing. Okay. Like gain will be less only. So at this part, gain curve will be like this something, and it will get a maximum value. Again, it will decrease. So at some particular value of duty ratio, we are getting the maximum gain. So what should be the range? Operating range. Operating range should be 0 to D max. D at which we are getting the maximum gain. Okay. So how question can be framed? Question can be framed like what will be the value of the duty ratio as which gain will be the maximum. Okay. Otherwise, what will be the value of the maximum gain? Is it clear to all? So we can solve this question now. What is the data given here? R is equal to 0.1 and capital R is equal to 10. So can anyone tell what will be the value of the this duty ratio for its gain will be maximum? R is 0.1 and capital R is 10. Can anyone tell what will be the value of duty? I am also calculating.
0.9.
1 minus under root R by R. So R is 0.1 divided by 10. So at D is equal to 0.9, we are getting the maximum gain. Okay. So what will be the maximum gain? Can anyone calculate maximum gain value? So that we will calculate by this equation. Gain maximum at it will come at D is equal to 0.9. So VO by VS max. Max will come at 0.9. So that we can write 1 minus 0.9 divided by 1 minus 0.9 whole square plus 0.1 divided by 10. So this will be the value of the maximum gain. Okay. All of you can calculate this one also. 1 minus 0.9 divided by minus 0.9 whole square plus 0.1 by 10. So this I am getting as 5. This gain value will be 5. So maximum gain will be 5. Everyone got this value 5 for this gain. Is it clear to all derivation till now?
Clear, sir. 5 only. So
Okay. So now I'm going to show you some waveform like what some coding I have done in MATLAB. So that from there also we can observe this. So is this screen is visible? Visible to all this MATLAB screen?
Yes, sir.
So see here, same thing I have written here, like G is the gain here. Okay, so what I have written here, 1 minus D divided by 1 minus D square plus a small r divided by capital R. And this gain I am plotting. So what am I doing here? I am varying the duty ratio. So duty I am varying from 0 to 1 in a step of 0.001. Okay, so I am going to plot this. We can observe the same result here. See, this is the waveform duty. So x-axis we can see that I am varying the duty. So duty I am varying from 0 to 1 and y-axis is the gain. Okay. So I am going to check the value here. This will be the maximum value. Okay. So see, I am going to move the cursor. See, almost 0.9 we are getting the 5. Is it visible? Is it visible to all? This cursor value?
Yes, sir.
So see, at duty is equal to 0.9, we are getting the higher gain. That already we have derived in with formula. Okay. So you can do this in C coding also. C coding also, if you know, you can just write the code and plot the value. So at if like at particular duty, if gain is needed, like you can see from here also. Okay. So I'm going to the next question. Anyone have doubt in this explanation or derivation explanation? Okay. So next will be
So
more
this
in
is for only continuous or discontinuous, sir?
this one for continuous, not for
For
discontinuous.
discontinuous, it varies, no, sir.
And discontinuous, everything will be different. Like if it will be discontinuous, everything will be different. Okay. Like analysis will be different. This volt second balance we cannot apply in that case. Three section will come when current will present, when it will not present. Okay. For D 1 minus D and when current will be 0. So total 3 section will come. Is it
Okay,
clear?
sir.
Okay. So next time moving to the buck boost converter, that will be a more interested. See, this kind of formula is already given. Maybe somewhere in some notebook you can find this D is equal to 1 minus under root R by R. So what I'm going to explain next, that will be more interesting. Okay. Okay. See. So this is the buck boost converter. Okay. Same thing I'm going to derive for the buck boost converter. So see. This here also some practical resistance is given. So practical resistance is a small r and this is the load resistance. Okay. So here also I'm going to write the VL equation. So VL for on time it will be Vs minus IL into R and for off time it will be Vs minus 1 second. Off time it will on time it will conduct like this one and off time the switch will be off so it will conduct like this one. So it will be for off time it will be minus IL R minus V naught. Is it clear? On and off duration equation for this inductor. Clear to all? So this will be Vs minus ILR first on case when switch will be on. When switch will be off, this will current will flow like this. So here it is plus minus V naught. So what will be VL plus minus VL will be minus IL into R minus V naught. Is it clear to all?
Yes, sir.
Okay. Similarly, IC current will be same. So IC will be minus I naught in on case and IL minus I naught in the off case. Okay. So here from IC we can write the same equation. IL is equal to I naught divided by 1 minus D by applying ampere second balance to these equations. So it will be V naught divided by R into 1 minus D. So this will be the inductor current equation. Okay, I am going to apply the volt second balance to this section. So it will be D into Vs minus IL into R plus 1 minus D into minus IL into R minus V naught. So this should be equal to 0. Okay. So here ILR D is common here and here 1 minus D is common here. So we can write as dVs minus ILR. So here D is common, here 1 minus D is common. So total summation will be 1 minus V naught into 1 minus D. This should be equal to 0. Is it clear? See, I'm going to write this one. So IL already we have calculated here. V naught divided by R into 1 minus D. So dVs minus the IL V naught divided by R into 1 minus D and here it is a small r minus V naught into 1 minus D. This should be equal to 0. So I'm going to multiply with 1 minus D both sides. So it will be D into 1 minus D Vs minus V naught R divided by total R minus V naught 1 minus D square equal to 0. So I'm going to write the final equation from here. So V naught common will be R by R plus 1 minus D square. So V naught by Vs we can write as d into 1 minus d divided by 1 minus d square plus r by r. So this will be the gain value or buck boost converter. Is it clear?
Sir,
Yes.
can you please explain the on and off state of for the circuit?
Okay. See, when this switch is on, okay, this inductor will charge like this, and when this switch will be off, it will discharge like this one. Okay. So this resistance is a small r. So what will be the, let's say we can write the same thing like this. I'm going to remove this. So practical inductor means it will having a small resistance with inductor. Okay. So this
Yes,
is the
sir.
VL. This is a small r. So what will be the VL? On duration switch will be on means VL is equal to Vs minus IL into R. This is the inductor current IL. For on duration it is clear. Similarly for
Yes, sir.
off duration it will be minus ILR minus V naught. This is clear, or I should write the KVL here. See, we can write like this. We can write, I'm going to write the KVL in this loop, okay, in this loop. So from here I will start, it will be minus IL into a small r, here plus VL, okay.
Yes, sir.
No, here it will be plus IL into r, at least the plus minus. The plus IL into r plus VL, it will be plus V naught. This should be equal to 0. So what will be VL? VL will be minus ILR minus V naught. Is it clear?
Yes, sir. Yes,
Okay.
sir.
Okay. So after that same thing I have applied the volt second balance. Volt second balance means multiplied by D in on time and with on 1 minus D in the off time. So after simplifying all this equation, what we got? We got the value of gain as V naught by Vs should be equal to D into 1 minus D divided by 1 minus D square plus R by R. So this second case you have to memorize, or this is for buck boost. Okay. What were for boost? For boost it was 1 minus D divided by 1 minus D square plus R by R. This was for the boost converter. This is the gain for practical inductor, and this will be the for the buck boost. So what further we have to calculate? We have to calculate the max value of the duty at which this gain will be maximum. So same thing I am going to do. I will differentiate this equation with respect to D. So D V naught divided by Vs by Dd should be equal to 0. Okay. So it will be 1 minus D square plus R by R. It should be whole square for this one. And here I will keep the same term 1 minus D square plus R by R. And what is the second term? Second term is the D into 1 minus D. So it will be D minus D square. So what will be the differentiation? Differentiation will be D for 1 minus D square. So D square will be minus 2D. Further minus it will be, this term will be keep constant. So D into 1 minus D. And the differentiation of this will be 2 into 1 minus D. And further it will be minus 1. This should be equal to 0. Is it clear? Should I explain again, or is it is clear to all? Can anyone reply?
Clear, sir.
Yes, sir.
Okay. Okay. So I'm going to just simplify this equation. So this will be 1 minus d square plus r by r. This will be first term multiplied by 1. Again it will be minus 2d into 1 minus d square. Again it will be minus 2d into r by r. And second term will be, this minus minus will be plus. So it will be 2d into 1 minus d square. And this should be equal to 0. Okay. So here what is this term? This term and this term are matching. Okay. So this will be cancelled. Further it will be 1 minus d square, here it will be minus 2d r by r. So 1 minus d square we can write as 1 plus d square minus 2d, the minus 2d r by r plus r by r. This should be equal to 0. Okay. So further we can write this quadratic equation as it will be d square minus 2d into 1 plus r by r plus 1 plus r by r. This should be equal to 0. So this quadratic equation will give some solution that will be the value of duty at which the maximum gain will occur. Is it clear to all? See, this equation only I have simplified. So d square is one term, minus 2d I have taken common, so it will be 1 plus r by r, and here it is 1 plus r by r. So d square minus 2d 1 plus r by r plus 1 plus r by r. So this will be the final equation. Is it clear? So if
Yes, sir.
we'll solve this differential equation, we will get two value of duty. Duty we will get two values for quadratic equation. So duty should be within 0 to 1. Okay, that will be the valid solution of the equation, duty ratio. So what is the value of R here? R I have taken 1 and capital R 10. Okay, so can anyone calculate what will be the value? R is 1, capital R is 10. So what will be the value of duty? We can calculate from this quadratic equation. Can anyone solve this equation? I'm going to write the final here. So d square minus 2d 1 plus 1 by 10 plus 1 plus 1 by 10. This should be equal to 0. So d square minus 2d into 1.1 plus 1.1. This should be equal to 0. D square minus 2.2d plus 1.1 equal to 0. So we have to solve this quadratic equation. Can anyone tell me the value of the duty? What will be the final value? You can calculate. You see, for gate examination, you no need to carry the big calculator. You can calculate minus b plus minus b square minus 4ac divided by 2. So like this, you should do the practice. Okay. So I'm going to write the final value of duty. So two value we will get. T is equal to
D equal to 0.76, sir.
D will be 0.768.
76.
So two value will be there. One will be 1 point something, some 43 will come. So that will be discarded, and final value will be 0.768. Okay. So
Sir, why this value will
see,
discarded?
for duty always will be 0 to 1. What is duty? Duty means T on by T. Duty, how we are defining? Duty means, let's say this is a total time period. This is on time period. T on, and this is total time period. Okay. So T on by T is called as duty. So it will be always less than 1. Range will be 0 to 1. Duty will be 0 to 1 always. Is it clear?
Yes, sir.
So that's why this equation will give two solutions, but this will be not be within range. So this will be discarded, and final value will be this one. Okay. So final conclusion is what we have to memorize. We have to memorize this equation. Directly you can, like this, easily we can memorize. So d square minus 2d, this will be similar. How we can memorize? D square minus 2d 1 plus r by r plus 1 plus r by r. This should be equal to 0. So this will give the value of duty at which maximum gain will occur. Okay. So now with this duty, we can calculate the maximum gain value also. So what will be the maximum gain? So it will be 0.768 into 1 minus 0.768 divided by 1 minus 0.768 whole square plus 1 by 10. So this will be the value of the gain maximum, VO by VS max. Can anyone calculate? How much?
1.157, sir. 1.157.
This one, I think you've done some mistake. Let me check also. 0.768 into 1 minus 0.768 divided by 1 minus 0.768 whole square plus 0.1. How much you are getting? 1.15 something.
Yes, sir.
Okay, let's check. So for this also I have done the coding. There we will see we are getting or not the same thing. So same equation I have written here, d into 1 minus d. So we can check the value. 1 second. See this we are getting. So 0.77 almost it is coming here. Okay. Is it visible to all?
Oh, yes,
Yes,
sir.
sir.
See, so in this kind of practical resistance, our gain will be like first will go to maximum, okay, then it will come to the minimum value. So in question, what they can ask, what will be the stable range of operation of the duty of range of duty for which the converter will work in a stable operation. Okay, so see, if below this we are operating means like it's okay only, but if after this duty we are operating and still our gain is low, so we should not for the same gain we can operate at lower duty also. So same gain we can operate here also and here also, so better to operate this side. Okay, and this will be the maximum range of the duty. So in question it can be framed like what will be the maximum value of what will the value of duty at which maximum gain will occur, and what will be the stable range of operation of duty. So in that case also duty should be equal to 0 to duty should between 0 to at value at dmax at maximum gain occur. Dmax is value of duty at which the gain will be maximum. So this will be the range. So in some objective type question it can be asked like this also, like what will be the range of the duty. Otherwise it can be asked what will be the value of the duty at which the gain will be maximum. Is it clear? Anyone have doubt in all this derivation? I will explain again. Otherwise we can move to the next question.
Clear, sir.
Okay. So these three
Sir,
formula you
please,
yes.
sir, so that two equation I want to write.
Which one? Okay. Anyway I will share this PDF. Which one?
Okay, sir.
You are there in the group
Mm,
NPTL?
yes, sir. Yes, sir. I am in the group.
Okay, you can write also. Otherwise I will share the PDF in the group.
Okay, sir. Fine.
Okay. So now I have taken two network analysis based questions that are easy question only. So I'm going to solve it one by one. See, in network also sometimes we are solving it difficult method. So any time you have to choose the easiest method. Okay. So I'm going to solve this one. First case, what we have to calculate? Thevenin's voltage. So how we can approach? Thevenin's voltage means open circuit voltage across this one. Okay. So how we can approach? I'm writing the KVL equation in this loop. So this total big loop, I'm going to write the KVL equation. Total big loop. So what will be the equation? Minus 1 into I naught. So minus I naught. Here this current will go in this one since it is a open circuit. So again it will be minus 1 into I naught. It will be minus I naught. And here it will what it will be? Minus 10. Minus 10. This should be okay. No, here also it will be at top also. Here path is not closing. So further here I am moving this side in this side. So minus 3 I naught should be equal to 0. Here it will be plus, here it will be plus. This is the KVL equation. This is plus minus, plus minus, this is minus plus, this is minus plus. So I naught plus I naught minus 10 minus 3 I naught should be equal to 0. So from here we can calculate 2 I naught minus 3 I naught. So it will be minus I naught should be equal to 10 and I naught will be equal to minus 10. So what will be the VTH? VTH will be I naught into 1. So VTH will be minus 10 volt. Is it clear? It's clear to all?
Okay. Sir, we can apply in entire loop, right?
See how I have applied. So see wherever the voltage will be present, loop means anywhere we can apply. So this bigger loop I have selected. So from here I am going. This is plus, this is minus, this is plus, this is minus. Okay, this no need to think. Here already from here to here we know the voltage. So this voltage it will consider. Again from here to here voltage is given. So I am starting from here. So here it will be plus I naught. Here also will be drop will be plus I naught since this I naught will flow here. This is a open circuit PQ. So I naught plus I naught. Here it will be minus 10, and again coming here it will be minus 3 I naught. So this should be equal to 0 total summation. Is it clear? Clear to all?
Yes, sir.
Okay. So VTH will be negative here. Okay. But sometimes we should not confuse. If negative answer is coming, we have to fill in the blanks negative only. No need to confuse. VTH can come as negative also. RTH also can come as negative. So that I am going to calculate. So for RTH in this type of question, what we can do, we have to connect the external source, and internal source will be replaced by their resistance. So for this is ideal source, so what will be the internal resistance? 0. So this will be sorted here. This will be sorted. Okay. And here I am connecting a 1 volt source. 1 volt voltage source. So we have to calculate the current here. What will be the RTH? RTH will be V divided by I. So V is 1 divided by I. This will be the Thevenin's resistance. Okay. So this is 1 volt means what will be this current? I naught. I naught will be 1 ampere. Okay. So what will be this voltage? This magnitude will be 3. Here magnitude will be 3. Okay. So in this resistance, how much current will be there? So I am going to write the KVL here. So see, this is plus 1, and here this point I am taking as a ground. So at this point 1 voltage, at this point how much voltage will be? Minus 2. Okay. So what is the current in this one? Current in this will be minus 2 ampere. Okay. This will be minus 2 ampere. Here how much is the current?
1 ampere, so that
1 ampere. Minus 2, like minus 2 ampere, this direction will be. So current direction will be what? Can anyone tell? See, first I will write the voltage equation here. So here this will be plus minus plus 1, like let's say this is V. Okay, plus minus V. Okay, this is sorted. I'm going to calculate the V. So it will be minus 1 plus 3 plus V should be equal to 0. So V will be how much? V will be minus 2. So minus 2 means what will be the current direction in this one? In this direction it will be 2 ampere. Is it clear? Again I will explain if anyone have doubt. In this 1 ohm, what will be the current direction? This current direction will be 2 ampere in this way. Is it clear to all?
Okay.
So see, 2 ampere is going here, 1 ampere is here. So what will be the here current? Here current will be 1 ampere. So what will be the value of this I? I will be minus 1.
Minus 1.
So RTH will be V by I, so it will be minus 1. So this was the fill in the blanks get previous year question, and answer we have to put as minus 1 we should put in the fill in the blanks, 2 marks question. We have to write one line KVL equation and final answer you will get. Just within 1 minute you can solve this kind of question.
Sir,
Yes.
sir, RTH का वैल्यू नेगेटिव आ सकता है?
Yes, it can be. So we should
सर
not.
अगर
Yes,
एग्जाम
yes.
में पूछा तो नेगेटिव
Yes,
में
yes. You have to put it, if you are getting negative answer, then you should put in negative only. Already this is a get previous year question. Okay, 2 marks question.
Okay, sir.
So if answer is negative, you should put negative only. This question is clear to all. One last question I have taken, that is also from network, that is a good question.
Yes, sir, it is clear.
Okay, so I'm moving to the next question. See, so this is a transient network based question. Here at t is equal to 0, we are closing the switch. It means switch is open. T less than 0, the switch is open. Okay, the switch is open means what will the inductor? Inductor will be short circuit. Okay. So if inductor will be short circuit, what will be this current? We can apply current division rule here. T less than 0, this switch is open circuit. So 50-50 current
ampere.
will divide. So 5 ampere it will be. And here also it will be 5 ampere. Okay. So what it is saying? It is saying that at t is equal to 0, we are closing the switch. And what will be the current IT? IT means this current in ampere at t is equal to 0.5 second. Okay. So t greater than 0, we are closing the switch. So what will happen? These two circuit will form. Okay. So one will be this RL circuit. RL circuit is short circuited, and this resistance will be isolated. See, this current will follow the least resistance part. So this will flow like this one. Okay. So what will happen? This RL circuit will be, we can write the equation. So for RL circuit, what will be the equation? So I is equal to I naught e to the power minus t by tau. This will be the equation for the RL source free circuit. Okay. It means that if
हाँ
RL circuit is there and
हैं
it is sorted,
कहना
and if zero like initial current is given, so we can write the equation as I is equal to I naught e to the power minus t by tau. So it will be a decaying kind of current. Okay. So this will be a that circuit, and what this current will flow in this one. So what will be the final IT? IT we can write as 10 minus 5 e to the power minus t by tau. And what is tau? Tau will be L by R. So it will be 1 by 2. So final will be IT will be 10 minus 5 e to the power minus 2t. This will be the final equation of this IT. Is it clear? I'll explain again. Is it clear to all?
Please form this equation by derivation, I think.
See, okay, yes, that is by derivation only. We can apply Laplace also. Laplace transform we can apply, and we can otherwise differential equation also we can apply and we can derive. If you want, I will derive now only. So see, this is R. Okay. L we can write as SL. Okay. And I naught, what will be the I naught?
5.
See,
I not by S, sir.
I naught by S. Okay. So I think not. Initial current only will be I naught. So I naught by S, if we are taking I naught by S divided by R plus LS. So S, if we are taking common, no, it will not be like this. L we are taking common, I naught by L. See, we can derive by this derivation will be there in the book. We can refer that for this. Like either you can apply Laplace or you can apply the differential. You can get this equation. Okay, final in terms of t, we can get this only. With differential equation also you can apply, and if you want the derivation, I will post in the group. Otherwise, you can refer any standard book. So this equation is clear to all. How I have written this final IT equation. This is it clear, or should I explain again?
Clear, sir.
So see, what is asking in the question at t is equal to 0.5 second. So what will be the value of IT at 0.5 second? It will be 10 minus 5 into e to the power minus 1. So it will be 10 minus 5 by e. This will be the final answer. It will be, anyone can calculate, 10 minus 5 divided by e. It will be 8.16 amps. This is also a get previous year question, 2 marks question. Okay. So see, if you have done the enough practice, you can solve this kind of 2 marks question also within 1 minute. Maximum 1 minute you can. Just you have to like see the logic, how it is working. Is it clear to all? If anyone have doubt, they can ask. Otherwise, can close the session. So any of you have some like demand, like anything I should cover like that, then I will come up with that kind of question. Am I audible?
Sir,
Yes.
Sir, in the question it was said that the switch was open for a long time and then it is closed at t is equal to 0. So
Yes.
is there any initial conditions for the inductor
See,
in the
this was,
circuit?
yes. So switch was open means this will be open, but this current is here. So this switch t less than 0, switch is open. So switch open means for infinity time this current is present from previous only. So this will be sorted, inductor will be sorted, and how much current will, this current will be divided in these two branches. Since this will be open, I'm going to draw the circuit. So this is 5 ohm. Okay. And here also 5 ohm, and this inductor will be sorted. And here we are supplying the 10 ampere current source. So this is condition for t less than 0. T less than 0, this point will be open. So what will be the current through inductor at t less than 0? It will be divided 50-50%. So it will be 5 ampere.
5 ampere.
So that's the initial current through the inductor. And what will be the circuit at t greater than 0? So t greater than 0, this is a RL circuit. So this I of L will flow in this direction. Okay. And this current will flow in this direction, and in this resistance no current will flow. This material resistance no current will flow. So this will be open circuit. This resistance will be open circuit because current will flow the least resistance path. Since this is sorted, so this 10 ampere will flow in this direction, and this RL circuit current will flow in this direction. Okay. So final IT will be 10 minus I of t. Okay. Now it will be clear to all.
Yes, sir.
Okay. Okay. So thank
Sir,
you. Yes.
the direction of inductor current will not be changed in opposite direction.
See, it is following the same path. Initially, it is following in this, like direction of inductor current is this. So after we are connecting this one also, it will be same only. This path only it will follow. So how it will complete the circuit? It will complete the circuit through this short circuit. Okay. This current will be same. So it will flow like this one. Direction will be same because IL0 minus should be equal to IL0 plus. So 0 plus also it will be in same direction. This direction only. Is it clear?
Okay. Yes, sir.
Okay.
So one more thing, for solving such questions, we have to consider two cases, initial condition and then I
Yes,
is equal to
yes,
0 already
yes.
given.
For any transient based question, we should see the circuit at t less than 0. Then with that condition, we should analyze the circuit at t greater than 0. Any transient question, we should follow this rule.
Okay, sir.
Okay,
Okay, sir.
okay. So thank you all. Meet on the
Sir,
next. Yes.
further session, you can collect some questions like discontinuous
Okay, okay.
converter, sir.
Okay, okay. So
It
next session,
convert.
okay, okay, okay. I'm also planning that. So next session will be purely based on discontinuous conduction. I will come up
Okay,
with
sir.
some good conceptual question. I will cover all like buck. I will cover boost also. I will cover, and buck boost I will also cover. So maybe next two session will be based on this discontinuous conduction. Okay. There we will learn some good concept. Like it will give you some confidence to solve any type of DC to DC converter question. I will plan for
Few
this one.
inverter problems also, sir.
Okay. See, the session will go before gate only. Like it will. So we will in coming session we will do all those things. So first I will do this discontinuous conduction for all type of DC to DC converter. Okay. After that we will see some inverter question like sine PWM and all PWM techniques that we will see.
Sir, but in portal, this is the last week is showing, sir.
No,
No
no, no,
links
no,
are
no, no,
available.
no, no, no. It will be updated. It will be updated. Every week
Okay,
it will be
okay.
updated. Okay.
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 Thank you, sir.
Okay. Thank you all. Meet on the next Monday. Thank you.
Thank you, sir.
Okay, thank you.
Thanks, sir.